This is an alert concerning the helium-4 gases at the Yellowstone Supervolcano. There's also a video embedded by the USGS by Jake Lowenstern, and he's explaining what's happening with this. It's about 7.5 minutes. This is not a recent news article, but it's recent enough. It was from December 2014. And it's not that long ago, and we are reporting on this because of the poisonous gas emissions that the USGS is just now recently warning about. The H2S and the carbon dioxide and various volcanic gases that are expected to be emitted at Yellowstone, especially in areas that most tourists don't go to, but there are people that visit them, and they have to be very careful because they could be deadly. They had animal deaths from these volcanic gases in the past. Now, this is concerning helium-4 gas at Yellowstone. From writer Lavender Ross via Before It's News, the clusters of earthquakes at Yellowstone caldera is not a good sign. Take very seriously the data points and ask yourself, would you be prepared if Yellowstone blew? Well, of course, most of us know the answer to that. The answer is definitely no. And we can watch the charts daily and see the kind of violent movements. That magma is moving. Just like the supervolcano in Japan went off, the Yellowstone volcano may be next. And also a new vent opened up recently, going right into Mount St. Helens. Scientists believe that the helium is slipping out of rocks that were formed during the Archean eon. That's about 2.5 billion years ago. But now they're coming out again from Yellowstone Park, which is not a good sign. Yellowstone releases gases ranging from carbon dioxide to methane. Not only was there a sudden rise in the elevation of the ground, in other words, there was ground deformation, it was puffing up like a balloon, and development of new cracks, but a gas called helium-4, a very rare type of helium, has begun coming out of the surface at Yellowstone, and that's not at all a good sign. Bill Evans, a researcher with USGS in Menlo Park, California, explained how the helium is released. Quote, volcanoes most always form on the edges of tectonic plates that make up the Earth's crust. Yellowstone sits directly over the middle of a plate. It's a part of the crust that formed a very long time ago, billions of years ago, and it's basically been stable since that time. They've had this boring, peaceful existence, and now suddenly they're put on the front burner, end quote. And next he went into the animal die-off. The animals and birds have been dying off, and now we are all in danger. This is chemical helium-4 that was seen prior to many recent volcanoes erupting. Okay, this is very, very serious. They noticed that there's a helium-4 uptick just before volcanoes erupt. And this is what they have noticed coming out of Yellowstone. And let's remember, Yellowstone is not any old volcano, it's a supervolcano. One of the few in the world. And also you'll see that we have here the ash cloud covering what has happened in the past. So basically that death zone area is just taking off most of the United States. Going back to this now. The chemical helium-4 has been seen prior to many recent volcanoes erupting. Measurements from other GPS stations in northern Yellowstone show smaller displacements forming a circular pattern of deformation. Circular, as in the round mouth of a volcano, consistent with a minor pressurization or building up underground about 6 to 10 kilometers. That's 4 to 6 miles deep. That's not little. It's 4 to 6 miles deep buildup near Norris Junction. The volcanic island of El Hierro, the smallest of Spain's Canary Islands, rumbled and groaned over the course of 7 months in 2011-2012. Gases silently percolated up through the island's soil and groundwater, and eventually a spectacular plume appeared off the coast of the island, a sign that El Hierro volcano, an underwater volcano just offshore, had finally erupted. Quote, "We believe that helium can anticipate the detection of magmatic movement even before those movements can be detected by seismic activity," end quote, said Eleazar Padron, a geochemist at Spain's Technological Institute for the Renewable Energies, who led the work on this. Researchers have been using gas emissions to forecast volcanic eruptions for the last 30 years, but they usually focus on other gases like carbon dioxide, the second most abundant gas after water vapor in volcanic eruptions. Now, helium is a noble gas, and it's a better candidate for tracking and forecasting eruptions because it doesn't react with rocks or groundwater, and microorganisms don't consume or produce helium. So helium is just pure coming out because of the imminent volcanic activity. Because of these properties, helium has been considered by geochemists as the almost ideal geochemical indicator that an eruption is near. Padron and his team found that measuring the flow of helium in El Hierro Island soil and water gave them clues as to when magma under the island was moving and how close it was to the surface, both important factors in forecasting a volcanic eruption. Researchers had been busy collecting and analyzing the helium gas content of more than 8,000 soil and water samples. Data can now be used to monitor volcanoes and forecast future eruptions. And you can see the link to live science that's here in the article. And they have various measurements here. They have 3 or 4 types of measurements that you can see. So yes, and also there's a map of the Yellowstone lava flows from 72,000 years ago, the deeper pink, and up to 164,000 years ago, which is the grayer part of the map.
My name is Jake Lowenstern, and I work for the U.S. Geological Survey. I'm the scientist in charge of the Yellowstone Volcano Observatory, and that's a partnership with the USGS, the University of Utah, who does the actual monitoring of the earthquakes and ground movement, and the land manager, Yellowstone National Park. We're looking here at a geologic map of Yellowstone National Park, and the different colors represent different geologic units, different rock types, different ages of rocks. You can see that all of the pink units in here, these represent the very youngest lava flows, mostly, that erupted at the Yellowstone volcano. Most of these are between about 160 and 70,000 years old, and we see that they're covering up this area of the park. It turns out this is the Yellowstone caldera. It starts around here and it moves out into the area over here, and it's about 50 miles long. And it formed when this green material erupted. This is called the Lava Creek Tuff, and the age of this unit, it's found here in the light green and the dark green, also to the south, the age is 640,000 years. This was an enormous eruption, and it spread ash over much of the United States, and a similar eruption to that today would certainly be a big deal. But since this time, there have been about 80 different eruptions at Yellowstone. Some of them are very big. This one is the most recent. It's 70,000 years old, and it's called the Pitchstone Plateau lava flow. In fact, the size of it is about the size of Washington, D.C., and it's about 100 yards thick in most places. So this is what we're looking at. We can see volcanic rocks everywhere, evidence that this is a really unusual place. It's a massive volcano. Some of the eruptions from Yellowstone are truly enormous eruptions, some of the largest ones that are known of on Earth. And that includes this green unit here, the Lava Creek Tuff, as well as the purple unit, which is the Huckleberry Ridge Tuff, which is erupted 2.1 million years ago. So these are some of the largest eruptions that we know of on Earth, and because they erupted so much material, on the order of 1,000 cubic kilometers or 250 cubic miles, then they get termed as super eruptions, really big eruptions. And the way that it works, this is kind of new terminology, and super eruptions, if you're a volcano that has exploded and created one of these deposits, then you get called a supervolcano. And that's where the word supervolcano comes from. So you have this magma that's beneath the surface, and when it erupts and comes out, there's no longer support for the ground surface up here. And as a result, the ground surface just caves in, it founders and it falls in. You're left with what's called a caldera. It's a subsidence or a feature or a cave-in feature that's caused when it loses its support of the underground magma. As a result, when it first formed, you had a hole that was on the order of 50 miles long and maybe even 1,000 or 2,000 or 3,000 feet deep in places. We have this deep magma chamber, and there's a lot of heat. The magma is generally at temperatures like 800 degrees centigrade or something like 1,300 degrees Fahrenheit. There's a lot of heat. That heat heats up the rock, and that rock then, there's conductive cooling, there's water down there, that water gets heated up, and so much of the water that's near the surface at Yellowstone is actually at boiling temperature. And as you go down, it gets hotter and hotter. So that's creates a pressurized system of a boiling aquifer, of boiling groundwater, and that becomes unstable. It can cause earthquakes, and of course it causes the thermal features that we see everywhere at Yellowstone that make Yellowstone so famous. The geysers, the fumaroles or steam vents, the hot springs that are so beautiful and contain so many different kinds of life and thermophile bacteria. So that's what makes Yellowstone special, and it's pretty much all due to this underground magma system. So we have these massive eruptions that are really quite rare, and then we have these lava flows that happen more frequently, but still not. The last one was 70,000 years ago. But this would be a really big event if it happened again within the park. It might cause forest fires, it might dam up rivers, and it would cause a lot of commotion and anxiety within Yellowstone, but it would have very little long range effect. It wouldn't affect people in states that are hundreds of miles away, certainly. We have other big events that occur at Yellowstone. For example, earthquakes. In 1959, there was a magnitude 7.5 that occurred out near Hebgen Lake, caused a lot of damage in the park, and also caused a lot of changes to the thermal areas within Yellowstone. The Teton Fault is on the border of the Teton Mountains south of the park, and it potentially could have a very big earthquake associated with it. Beyond that, we have the hydrothermal explosions or steam explosions when the groundwater system becomes too pressurized and erupts during some sort of perhaps an earthquake or due to a change in lake level. And what happens is you get the groundwater system can form really large holes in the ground, sometimes hundreds of feet across. This is a turbid lake right here, Indian Pond and Mary Bay. All of these were created in the last 15,000 years by explosions of the hydrothermal system. In this case, no magma is erupted, and they're fairly localized events in terms of their damage, but they're still definitely relevant for what's going on at Yellowstone and need to be watched. Almost every year, somewhere in Yellowstone, there is a small hydrothermal explosion. Sometimes they might only be a couple feet across, but we find evidence for them. Sometimes we see a little bit of smoke coming out or fumes coming out in a place we didn't expect it. Sometimes somebody hears it. And in lucky cases, we actually get to witness one of these explosions, and that's happened every few years as well. We have no way of predicting these explosions, especially the smaller ones, but we hope that as time goes by, we'll get more and more knowledge about how they work, and maybe get the chance that someday we'll be able to be able to have some predictive capabilities for these explosions.
Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.